lecture number 4 of week 12. So, mostly in this lecture we will be talking about sediment sampling. So, the previous lecture we were talking about sediment transportation. So, once you have sediments in the river or any water body, so how to sample that. So, that we will be discussing here, and then so the sediment measurement. So, sediment transport is a dynamic phenomenon. So, because it changes with time and also it changes with space. So, it is a dynamic. So, you may not be, so suppose you have collected the sample today. The concentration of sediment is may not be same as tomorrow, or it may not be yesterday. So, it may not be same as location 1 and location 2. So, the measurement techniques cannot be registered the ever changing conditions that exist in river bodies. So, measurement techniques will vary, I mean different measurement techniques. So, one single measurement technique may not be enough to tackle these dynamics of sediment dynamics. Okay, so let us see some of the the devices we will be using to measure. So, before measuring sediment load, so if you see the sediment or the particle size is very important. The particle size generally measured, or particle size is estimated using sieve analysis. So, the knowledge about particle size is prerequisite for understanding the source, transportation, and some cases environmental impact of the sediment. So, knowing the sediment size is very important. So, what is the source and where exactly the sediment has come from. So, basically here we will be using set of sieves in ascending order. Let us see. So, if you see the sediment particle size is determined basically passing a simple sample of sediment through a series of sieves. So, the mesh sizes could range from 1.25 mm to 63 microns or less. So, 63 microns we have seen it is less than, if this is less than, and this will be silt and clay. So, mostly we are talking about the sand here. So, series of sieves. So, here I mean sieve number 1, sieve number 2, sieve number 3, sieve number 4. So, here 1.25 mm size, the size of the opening is 1.25, and maybe this is 1 mm, and this will be maybe 0.1 mm, and this will be 0.062 or 60 mm, okay, or 63 microns, and the last you have a pan. So, you put the material and sieve it, and it will segregate or divide the sizes into different ranges, size ranges. Then, so knowing the particle size, so you can decide what the particular size refers to. So, suppose if the particle size is 256 to 64 mm, we call cobble, and 64 to 2 mm is called gravel, and 2 to 1 mm very coarse sand, and similarly for clay and silts and fine sands are denoted with the different sizes. So, so the mostly the cohesive sediments are the silt and clay, and non-cohesive sediments it is like mostly the coarse sand and cobbles, the bigger sizes particles. So, sediment measurements, there is no universal accepted scale for the classification of particles according to their sizes. So, there are USDA size, then ASTM and BIS. So, there are several what you call these standards available to decide the sizes. In North America, so the Wentworth grade scale is commonly used, elsewhere the international grade scale is preferred. So, it depends on different organizations. The standardization will be decided by different organizations. There are minor differences between the two scales. So, the size ranges may not be varying too much, but minor variations. So, therefore, important to note that scale has been selected and to be used consistently. So, once you use a particular system, so go ahead with that system throughout your study. So, sediment measurement here. So, this figure variations in concentrations of suspended sediment with water depth for sand, silt, clay as measured in one field site. So, in one field site, if you see this is a river bed and this is the river surface. So, that is why it is 0 to 10 meter top, and then from this is the location where you collected. I mean, this is one field location, and from there this is the distance. So, the coarse sand, if you see, so the silty will be residing on top, right, silty and clay because it is suspended, and fine sand and the next, and medium sand and the coarse sand and the last. Okay. So, initially, so the heavier particles will be, heavier particles will be at I mean nearer to the bed, and then lighter particles will be nearer to the surface. The sediment measurement here, if you see, this has an hysteresis. So, hysteresis effect observed in suspended sediments. So, because if you I mean this is the this is a hydrograph, you see. So, the fourth is the peak, right. So, since it is a peak, you get maximum sediment concentration here because the discharge is maximum, you get a maximum sediment concentration. So, so since it has peaks like rising limb and falling limb. So, the rising limb, during the rising limb, so you get most of the sediments out, and since the water is accumulating and increasing the wash load, that will increase the wash load and you get a maximum concentration. But during the receding phase or falling limb, those suspended sediments, so sediment concentration will be less, but it won't follow the same path as it was before, right. So, A to B, if you see B and A, so A is the starting point, B ends with somewhere. Okay. So, that is why, so the hysteresis of the sediment suspended sediment is due to the I mean hydrograph characteristics, you can say. The sampling methods here mostly for sampling sediments, you have a dredgers, grab samplers and core samplers. So, dredgers are like the drag unit which has a net at the end, and the grab samples, so it grabs, it has a heavier, the box which falls into the ground, and when it falls down, it opens up, and then I mean there is a hook on top or the mechanism on top, you can close it so that it automatically closes the bottom and you take out the sample out. And the cores are like it goes, these are the vertical rods, and using that rods, it has a sampling, the sampling spaces in between. So, once the holes, once you take out the sample out, core sample out, you can take out the particular and the sample at a different depths. So, dead samples are, like I said, so it has a the fine mesh at the chord end. Okay, so hemispherical mouth aperture with height of 56 centimeter and width of 75 centimeter. So, if you see this is kind of this is going to use to collect the bed load, basically 75 diagonal mesh. Okay. So, 75 diagonal mesh. So, the mostly the bed load can be taken out. So, the dredge is device that is dragged across the bottom of the surface being sampled, and this type of sampler used primarily for collecting indigenous benthic fauna rather than samples for chemical analysis. So, this is simple because it collects the bottom. So, the bottom, So, we will be looking at the benthic fauna like like some aquatic animals. So, aquatic life. So, that can be or aquatic creatures can be collected along with the sediments here. Okay. So, the next is the types of dredges. If you see, so it could be rectangular, like opening is rectangular or triangular. So, it is the opening is triangular or bucket type. So, here if you see, so this from here, so the dredge particles will be taken away. So, like dredging, right. So, this is the bucket type, and then grab samples. So, here the grab samples are this have a set of jaws, the shut or bucket that rotates into a sediment. So, if you see working principle of grab samples initially, so these two buckets are open, right. Initially when it is going down, it will open. This is the the sediment you need to collect. So, once at the bottom, so because of the weight, what happens? So here there is a hook. When you take it out, right. So, this hook will be taken out. So, then the chain will be released. So, once the chain is released, so because there is no support here, and this will be fallen down, and this will be closed because of the heavy weight. So, once it is closed, and you can take out the sample to the top. So, are easy to handle and maintain and use. You provide access for subsamples. Okay, so the grab samples are different types. If you see here, this is called Ponar grab. So, Ponar grab samples are similar to that. So, it has a two buckets here, right. Once it hits the ground, the buckets are going to close. So, similarly, the Peterson grab sample just we have seen in the previous slide, and orange peel grab. So, this has this is a 3 buckets. So, this is 1, 2, 3, and they are going to the similar principle. Once they gone down, and the chain will be released, and due to the weight, it collects the sediments, and when you take it out, the all 3 buckets are going to close, and you can take a sample out. And this is Van Veen grab. This is another kind of grab, and this is a Smith-McIntyre. So, Smith-McIntyre grab sample. So, this is little complicated, but it's I mean will be used in deep waters. Okay. So, the core samplers, the other category is the core samplers. So, the core samplers are basically tubes or augers that are inserted into sediment or soil by various means to obtain cylinder or box sample of material known depth. So, the advantage with the core samplers are you can get samples vertically down from the top to bottom at different desired depths. So, for example, here the core handler here. So, this is the core sampler, and this is the core to I mean this will be core cutter. This is kind of a core teeth. So, this will make it will make easy access to the ground. Okay. So, once the sampling is done, if you take out, you can know exactly what depth of sample is being taken, and cores can be simple hand operated devices, or they can be large, costly and motor driven mechanisms. So, that can collect samples from great depth. So, if you are going to collect sample from deeper waters, then even in that case the cores are helpful, right. But you need to use heavier kind of rigs so that you can get the core sample from deeper deep waters. So, the core samplers could be electric vibra core. So, it is basically the vibrations which are generated will be used to loosen the soil here, right, loosen the soil, and that will be collected in the cores. And Lamont box corer, so this is another similar to your what you call the box type sampler we have seen just. And the piston corer, so this will be a to and fro motion kind of thing. So with this, so because of the piston moment, it goes down, and in that way it goes down. It's a free fall wire. Okay, so it works on the principle of in to and fro like a piston moment, and collect the sample at the desired depth. And a Fleaser corer, this is another kind, and gravity corer. So due to gravity, it goes and collect the because of the weight of the sample, it goes weight of the core, it goes and hits the ground and collect the samples here. And the other one is homemade suspended sediment sampler. So this is very easy. So this is a bottle. If you see, this is the bottle, and then it has two tubes. One is air outlet tube, and then intake nozzle here. So mostly this is used for getting the suspended sediments. This is a rubber stopper here, right. So this is inlet. So suspended sediments will go in and trapped here, right, and then clear water will, or air, whatever it may be, so that will be passed out. So that way, so and here this will be tied to a vertical pole, so that it won't float from one place to another place. Okay, and this is very easy used for suspended sediment collection. Okay, so then, so the considerations and cautions should be applied to sediment sampling basically. So the soil sampling equipment is generally not applicable to sediments because of the low cohesion of the medium. So here soil samples, for example soil cores and other things, or augers, so they may not be applicable here in case of collecting sediments, because the sediments are like a cohesive soils, mostly the silts and clays. So, we will be much careful. So, better use sediment sample rather than soil samples. A direct collection with the appropriate sample container may be appropriate in very shallow water where sediment is exposed. So shallow waters, if you have shallow water sediments, so data collection will be easier, and also it is appropriate compared to the deep water, and you may get accurate depths. You can collect the samples here. Use dredgers or for hard rocky substances. So dredgers are very useful, which can collect the rocky samples. They are heavy enough to use heavy velocity streams. Use core devices in quiescent waters. So the quiescent waters means you are not having turbulence in waters unless water depth precludes effective sample collection. So unless there is a deep water or anything, there is a difficulty in reaching the ground. So the core samplers can be used in quiescent condition. Samples must be preserved according to CFR 40. So the CFR 40 is this is the Title 40 of Code of Federal Regulations of United States. So the sample holding times according to CFR 40. CFR 40 has code of conduct for collecting sample preservation and all other things. So we need to follow the recommendations while taking the samples and while preserving the samples and analyzing the samples. Okay. Okay, so this is all about the sediment sample collection. So as I said, basically we will be collecting sediment, suspended sediment as well as bed load. So there are several devices will be used to collect the samples. It could be dredgers, soil cores, core samplers, and the grabs or simple handmade suspended sample collectors. So, and in order to collect the sample, in order to preserve the sample, we need to use the CFR 40 or the 40 I mean the standard, this is the standard mostly the United States being used for collecting and preserving the sediment samples. Yeah, thank you.